So for our first part, it says evaluate the expressions x squared 4, x equals 1, x equals negative 1, and x equals negative 2. So for this, all we're doing is direct substitution. So I'm going to write it above. So we write f of 1 in your function notation equals 1 squared. Can anybody tell me what 1 squared is? It's 1. Yep. Nice job. Next one up, we have f of negative 1, which is negative 1 squared. Can somebody tell me what negative 1 squared is?
1.
1. Nice job, guys. And last but not least, we have f of negative 2, which is going to be negative 2 squared. What's negative 2 squared? 4, because the same thing as negative 2 times negative 2. After this, we have to do the exact same thing where we're evaluating the expression for these. X equals 0, x equals 1, x equals 2. But now we have this expression here. So we're going to substitute in. If I put in 0 here, what do I get?
2.
Yep, we end up with 2. Thank you. And if I put 0 into the second one, what do we get?
Negative 2.
Negative 2. And what do you do when you multiply those two?
Get 0.
Try it again. You added up 2 times negative 2. 4. He is correct. Okay, f of 1. So we're going to go through here. You put 1 in. 1 plus 2 is 3. 1 minus 2 is negative 1. Yep. So we have 3. We have negative 1. I'll erase that stuff happening above it. Don't know where that came from. Okay, what do you get when you multiply those two? Negative 1 times 3. What's 1 times anything? It's going to be 3, right? But we have a negative sign with it, so it stays negative 3. So I heard some people saying some common answers for that, but just remember 1 times anything is whatever the other thing is. And then as long as there's only 1 negative, it stays. If there's 2 negatives, it goes away. Do you guys have any questions on those first 2? Okay, if you do, just let me know. After that, this is what we dealt with on Friday. These are all those predicting what comes next problems. So on our first one, we have 100, and then we went to 93. From 93, we went to 96. From 96, we went to 90, or not. Let's try that again. Erase that. We had 100, we went to 93. From 93, we went to 86. And from 86, we went to 79. Can somebody tell me what's happening there? Yep. Said minus 7 each time. So we're subtracting 7. And then what did you get for our last one? Oh, you're fine. Let's see if he has it. What do you have, Ryan? 72. Nice teamwork, you two. So we subtracted 7 each time. The next one I feel like has an element of being a little trickier. So you see you started at negative 43. Now you went to negative 35. And then you're at negative 27. And then you're at negative 19. Are these numbers getting bigger or smaller? They're getting bigger, right? So you're adding a positive number. Did you have your hand up, hon? It's going up by 8. That's exactly correct. Can somebody else tell me what our next number is going to be?
Negative 11.
Negative 11. I like the teamwork on these questions. Good job, guys. So we're going up by 8. And the next one seems kind of scary because it looks like a word problem. But word problems aren't that scary. They just wanted to see if you could translate what's being said. So we have Alicia's savings account was at $55 at the end of March. It is at $63 at the end of April, $71 at the end of May, $79 at the end of June. Predict what it's going to be in July. So what we're going to do is we're just going to write that out like something we've seen. So we're going to write it just like this. So our first one here, so we have 55, comma, 63, comma, 71, comma, 79. Now it's in a form that we're familiar with, and we're trying to predict what happens next. Can somebody tell me what the pattern is? Yep.
It's going up by 7. Oh, wait.
Close.
8.
It's going up by 8. No, you're fine. So it went up by 8. So can somebody else tell me what the number is going to be? Back there, Ray? 87. So at the end of the month of July, she's going to have $87. At the top of each page, they have the OBJ, objective. So today is to use inductive reasoning and to make conjectures. So those are both vocabularies there. Inductive reasoning is going to be a new vocab word, and conjectures is a new vocab word. So the first one is conjecture. It's an unproven statement based on pattern or observation. The second one is inductive reasoning, the process of looking for patterns and making observations. We've been doing that our whole last lesson. And then now we have counterexample, an example that shows a conjecture is false. So much of geometry consists of reasoning in 3 stages. Our first one is we're going to look for a pattern. We look at several examples. We use diagrams and tables to help discover patterns. So anything that can help us recognize that there's a pattern, that's what we're trying to do. The second one is to make a conjecture. Use examples to make a general conjecture, and then we can continue to modify it. So we might have one idea, and then we realize something else. So we are able to change it as we go. And the last one is verify the conjecture and use logical reasoning to verify that the conjecture is true. I was going to give you that even. So we can see it with these examples. 3 plus 3 equals 6. 3 plus 12 equals 20, or not 12, 17 equals 20, and 1 plus 1 equals 2. But you could have many examples. 5 plus 5 equals 10. Somebody in my last class did 117 plus 1. Just so you know, so you're going to show a couple examples when you answer these type questions, and then you're going to tell me your answer. You're not just going to tell me even. I want to see that you did something to show your work. How did you know that? Robert, did you have a question, or you want to answer our next one? Okay, I thought you were raising your hand. Okay, so the sum of the first n positive odd integers. So we're going to be adding odd integers. So n represents the number of odd. So our first, so n equals 1. Can you guys see purple okay? You want me to change it? So when you have n equals 1, that means you only have one odd number. That one odd number is 1, right? Our first odd number. When you have n equals 2, you have 2 odd numbers. So that's 1, and you're adding our second odd number, which is 3. We add those together, and you get 4. When you have 3 odd numbers, we have to do our first 3, which is then 1 plus 3 plus 5. What does that add up to? 9. Yep. I'm only going to make you do one more for right now. So our first 4, so it's going to be 1 plus 3 plus 5 plus 7. And what does that give us? 16. Yep. So there is something special about these numbers. Does anybody see what they are? What did you say? So there are a lot of odds, but we got a couple in here that aren't. The 4 and 16. But there's something else special. We talked a little bit about it in our last lesson. Does anybody recognize these? Perfect squares. They're perfect squares. And perfect squares are pretty great. So you see 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. What do you think 5 would be? Yep, 25. So what can we say here? That the sum of the integers, how can they be represented? By what? By squared. So if we don't know the exact number, what do we use? You're right with the one part. I'm just thinking if you could tell me the word that I'm looking for. A variable, yep. So what's your favorite variable? Generally we'll use n for this one. So n squared. So that one was kind of tricky. Okay, for number C, or letter C, the product of an integer and its opposite. So this requires you to flash back to Algebra 1 when you learned about opposites. So can anybody tell me what an opposite is? Does anybody remember? It's okay if you don't. If you do. Ryan? Yes, I think you're saying what I want to hear. So what I think he's saying, Deborah, you want to add to it?
It's probably wrong, but I'm thinking like the absolute value of something.
You guys are just like spot on this. This is exactly what I'm teaching this week is what you two are describing for my Algebra 1 class. So it is. It's that distance to get you back to 0. So the absolute value, but whatever it is, opposite of. So it's that positive or negative. So what he was saying was that this would be a negative n would be the opposite of n. So if you had 4, 4's opposite would be negative 4. If you had negative 2, its opposite would be positive 2. So it's whatever brings you back to 0. So it's that positive and negative that he was describing, and then the distance that she was talking about. So the product of an integer and its opposite is going to be n times negative n. What do we get when we multiply those two together? Negative n squared. Yes, good teamwork. It's like, I knew you guys knew it. You guys were just dragging it out. Negative n squared. Okay, so this is A through C on question number 1. Do you guys have any questions at this point? So then the next one is to complete the conjecture. The product of any two odd numbers is blank. What does the word product mean? Multiply. Sorry, Deborah, you're all about it. But don't worry, you're going to go to you next. So this means multiply. Okay, so you ready for your favorite odd numbers, Deborah?
I guess.
Okay, so what are your two? No. 9 and 9. 9 and 9. Okay, what's 9 times 9? 81. I like it. Okay, so let's try another one. Odd numbers. Okay.
5 and 9.
5 and 9. What do you get? 45. That's right. I heard it. Okay. Jaden, I just feel like you've been answering a lot. Do you want to do one?
Yeah.
Okay.
7.
And what?
7.
7 and 7? Okay. So 7 times 7 is?
49.
49. That's always one of my favorites. So what do we notice about all these numbers?
They're odd.
They are odd. Last one on this page. The product of the numbers n minus 1 and n plus 1. So we're going to write those out. N minus 1 times n plus 1. Most of you guys know this as double distributive property. Does that sound familiar? Some of you might have heard it as FOIL. That used to be the old school way people remind people of this. So our double distributive property tells you that we're going to multiply n times n. When we do that, what do I get? N squared. Strong. I like it. N times 1. What do we get? N. Okay. Negative 1 times n. Negative n. Negative 1 times 1. Negative 1. These middle terms are opposites of each other, so they drop out, go to 0. So we're left with n squared minus 1. Show the conjecture is false by finding a counterexample. So the directions already tell you that both of these following statements are not true. Show the conjecture is false. Okay, so the sum of two numbers is always greater than the larger of the two numbers. So with this one, you have two numbers you're adding together, and when you add them together, whichever one's the larger number, the sum is always larger than that. That's A. B is if the product of two numbers is even, so you're multiplying and you get an even, that means that both the numbers must also have been even. I would like you to take a few seconds, work by yourself, talk to a buddy, whatever works, and see if you can find at least one counterexample for this. At least one. So the sum of two numbers is always greater than the larger of the two numbers. So we're adding two things together, and we're trying to show something that stays the same or something that's less than the bigger number. So we wanted to prove something that's not true with this. Jack, you know I'm going to pick on you for this. Can you give me one of your ways?
5
Plus negative 2 equals 3. So he added a positive and a negative number, and now his answer is smaller than his biggest number. There is one other way than with negatives. Did anybody else find the other way? Okay. I think you were on to it at the end of our conversation.
0 plus 0?
So we can do 0 plus 0. It's the same as its largest number. I always do mine with 1 plus 0. So 1 is the same amount, or 0 is the same amount of its biggest number. It's not always greater than. It is the same value of. So either of those work. So nice job. Those were supposed to be tricky, so if you're coming up with those are the two different ways you could show it, with a negative or with 0. The last one is the product of two numbers is even, then the numbers must be even. So if you multiply two things together and you got an even number, is there any way to do it with both those numbers not being even?
Yeah.
Okay, I heard a yeah. Can anybody give me an example? Oh, Cannon.
3 times 3.
3 times 3? You're close. What's 3 times 3?
Oh, 9.
But you're almost there. 3 times what? 3 times 4. What's 3 times 4?
12.
12. So you're just off by 1. And then 12 is an even number. And we see that both the numbers that formed it were not even. So any realm of these type numbers, I always go with 2 times 3, 6. Did anybody else have a favorite one that they just liked?
4 is even. I'm so confused.
So you have one even number and you have one odd, but not both of them are even. Does that help?
Yeah.
Okay. So the sum of two numbers is positive, then the number must be positive. So your blank is positive, then the number must be positive. So if the final answer is positive, can you think of two numbers that are not positive that will get you there? Yep, Alexis?
-1 plus
-1 plus -1. So you're close. So this gives you a sum that's negative. What could you switch this 1 with? Anybody?
2.
2. And that works for us. Nice job, you two. Oh, I still wrote the wrong answer, though. Let's try it again. 1. So here, you see that you had a sum of two numbers that was positive, but the numbers that came from it that we added up were not both positive.